Ladies and gentlemen, many thanks to come and follow this presentation about 3D printing. My name is Djordje Markovic. I'm Serbian guy. I'm living and working in Switzerland. I'm working for 3D Systems, the company who is a world leader of 3D printing solution. I'm on the head of engineering in Switzerland, and I'm working on material production, on resin and printer development, on testing and all the stuff. So I will explain you a little bit about 3D printing, because actually it becomes a big boom. Everybody talk about 3D printers and everything, but the result is the 3D printing technologies exist for more than 30 years, and we will start from the beginning with application and all stuff. Well, so today we will speak, if my presentation work. Okay, we will speak about beginnings, about principes, how we print, what kind of technologies we are using, what kind of materials, type of printers, price of printers, and all applications developed with 3D printers and use with 3D printers, that 3D printers are used. Well, about the beginnings. The first serial beginnings were in 1986 by one man called Chuck Hall, who discovered that we can polymerize the liquid photomers, the liquid plastics, and we can put the layer on the layer and receive and have some 3D object. So Chuck Hall started with a small company called 3D Systems, and he worked on his first 3D printing machine, and he developed a process called stereolithography. Stereolithography is a process who use liquid plastics in the big vat, and we will polymerize with ultraviolet laser, layer per layer, and when we do this, we get 3D model. I will show you some video who will talk about this. Before this, 3D printing is what? From a CAD model, from virtual model to the real model. As you can see, 3D printing parts are used in automotive industry. More precisely, we have Formula 1 teams who design their parts, who print their parts to make the physical tests before they make the real parts they will put on the Formula 1. In car industry, we have also manufacturers of manufacturers who will design the new prototypes using 3D printers to print all design parts, dashboard, all plastic parts in the car. For first car are made first in 3D printing before validation of the concept. You agree that before we start to manufacture one car in 20 million exemplars, we have to make a first prototype to validate it and to see how it behaves, to correct the faults, and after that we continue with with production. Sorry. Electrics and electronics. All devices we have today, simple mouses, iPhones, the mixers, every electronic device, the frame of this screen, first they are designed in 3D actually, and after that we're gonna print them to validate the concept, to see if we made some errors. Because if we made some errors and we go on the mold injection production and we realize that we made an error, we lost a lot of money. And actually the 3D printing save us the money. Here you will see the procedure of 3D printing with liquid resins. So we have a layer per layer polymerized by laser, and once it's finished we have our part. The advantage of 3D printing to other manufacturing technologies is that we can really print, manufacture in real everything. I mean, every shape, every form. It's doable with 3D printing that we cannot maybe manufacture by other industrial procedures. So you can even print some bearing who is in plastic, who works in like one part, and you don't have to assemble or something. You just or some gears in gearbox. You can also print it in one part, and it works. It turns, and it saves a lot of time to the manufacturers for development of new equipment and other. One of procedures also used in industry is SLS, or selective laser printing. That means that we have polyamide plastic powder in a vat, and we have one infrared laser who will melt layer per layer. This is in industrial world the cheapest 3D printing, and the parts are very similar. The resistance of the parts and the equipment is very similar to the mold injection production. That means that we can manufacture some finished parts that we can use in our assemblies and all that stuff. We will see how it works.
A CAD design is transferred to the sinter station. A roller then deposits a precise amount of powder over the build area. The laser sinters or almost melts the powder to form a single layer of the prototype. The build area piston lowers, and the roller deposits another layer of material to be sintered. This process continues, and in a matter of hours, the entire part has been built.
So that means that we will melt one layer. After that, we will bring a new layer of powder. We will melt it, and we will increase this up to our part. The manufacturing time in 3D printing, the main parameter for manufacturing time in 3D printing is the height of the part. As the part is higher, that means it has more layers, and with more layers it brings more the time. But actually we are working with some manufacturing times very correct. I mean, we can design a dashboard of a car in 2 days. After that we have post-par cleaning and preparation, but it's other subject. About the 3D printers, we have everything. Most of the people heard only about Rapman or open source printers for a few €100 that we can order on internet, buy by ourselves. But in reality, the 3D printer starts from 1,000 euros up to 1 million. As you see on the slide, we have personal, professional, and production printers. Personal printers, as the name says, are for schools, are for the people who want to just start with 3D printing, and the quality of the parts, it's not something very exceptional. The layer thickness is around 0.1 millimeter, and we have 3D parts, but the definition of those parts is just to show them, nothing more than this. After that, we will go to professional printers, where we have printers that will print a lot of kinds of plastics. We can print also metal. We can actually, NASA made also 3D printer for astronauts to print the food. So we can print everything what we can imagine, even the ceramics and all those stuff. After that, it depends also in what field of industry you are, and you will find your solution with 3D printing. When the hammer is only solution, think about 3D printing. 3D printing started to be a first step in rapid prototyping, and it finished like a solution for industrial production. If we can't make some parts on other way, then if we can't make some parts with conventional milling and drilling procedures, we will start with 3D printing. And we can find the solution, even with metal parts. And it will save us money and the cost. Because in industry, when you have some production stop because of something broke and we have to repair it, less time we spent to make the system running again, less the money we lost. That's why we use the 3D printers even for metal. One example is the parts. I don't know, can you realize what is injection plastic mold? In injection plastic mold, we have a lot of the times some shapes hard to get with milling, conventional milling, and it can take up to 5 days. So, and if we print the part in metal, we can do it in less than 1 day. So we saved 4 days of production. That's why maybe the part will be more expensive in the start, but at the end it will be a cost-effective solution because we had 4 more days of production. About people, companies who work with 3D printers and 3D printing solutions. We have people like Airbus, Nissan, BMW, Videx for ear hearing devices, Siemens, and the list is much bigger than what we can see here. I mean, I didn't have enough of slides to show you all clients we have. I think that car industry is one of the, and medical industry are one of the biggest clients, also with Airbus and Boeing. About materials. Well, as I told, we can print in every material we imagine. We can print the small and technical parts. We can build also big parts. We can have materials resistant to temperature up to 100 degrees. So the material properties are even better than what we use like a plastic in the production. We have also we can have also materials that are compatible with human body, and we can use 3D printed parts even in during the operations of patients. We can validate the structures. For molding industry, it's very important to have 3D parts and 3D printing. For jewelry, for custom-made jewelry also, because imagine some prince of Dubai who wanna have his exclusive wedding ring for his lady. We're gonna design it in CAD software, in jewelry CAD software. After that, we're gonna print part in the wax, his ring in the wax. Once the ring is printed, we're gonna make a sand mold. We're gonna heat this. We will melt our shape of our master, our printed part, and we will keep the shape. Then we will come with melted gold, and we have the perfectly designed ring. And about the resolution of printing, we are around 0.02 millimeters. That means 2/100th of 1 millimeter. So we can really do everything with the 3D printing. Okay, the price is still the biggest problem of 3D printing, but we can do a lot of things. What we have now. Let's start with personal printers. As you see, personal printers start with small prices. They are very simple. And how it works, it's we have just ABS plastic, extrusion head who will heat and melt the plastic and put it on the plate layer per layer. You can see kind of toys that we can print with them. We can also have 3 colors of ABS and make combination of colors. And it can be nice, but those parts are not for some technical use, or we cannot use them in any serious project. the big advantage of 3D printing is that helps a lot of people in school, in education. I mean, even the doctors are printing actually the bones and the parts of the human body to show to the students. If we can print even with the colors, with 400 colors, so we can print whatever we imagine, and we can show this to the people. We can make the people understanding how it works. If you wanna, if you're architect, we can print the whole quarter we designed and we wanna construct. So the advantages are huge. We can see the people, the final client can see how it works, how it looks like, and then we can make some corrections, because corrections are easier to do during the CAD design process than when it's finished and built. All right. What the fuck? Oh fuck. We have some technical problems, but we're gonna solve them, I hope. And yes, during crash tests, one good example is 3D printed part and serial production manufactured part during a crash test. We have similar results, and that allows to us to design, for example, a kid's seat to make the tests, and after that, when our tests are when we are satisfied with our tests, shock absorption and the rest, we will put this in serial production. So you can see here that with 3D printing we can test a lot of things in safety. So that means that's quite serious technology. Otherwise, here is one example between one conventional made part and one 3D printed part. On your right side you will see 3D printed part, on left assembled part. As you can see, you need, for normal part, you need 4 tools. You have 4 non-standard parts that you have to manufacture, 12 standard parts. You have assembling work, you have a glue, and time and the money it costs something. If you print your designed part with 3D printing, you have the same part with same characteristics, but it's only one part. You don't need any tools. Your part is ready to use. One more advantage about this. About hilt equipment, we started to use 3D printing also for hilt equipment. From ear plugs to in dental industry, it's also used for leg prostheses, also for supports. I had a question from one hospital in Switzerland who asked me about some materials because they wanted to make the guides for bones when they have to do some operations and they want to drill the bone under a certain angle. They want to print those positioning parts in 3D printing, because every bone on every human is different. So here we can really adapt everything to the patient, final client, and it's in progress. Otherwise, Google and 3D Systems are also on project of line of cell phone, smartphone assembling, where you can online configure your cell phone, and behind there is a production line with 3D printers and everything, and they automatically manufacture the smartphone cell by your specification. If you want a small, big screen, color, shape, and all the stuff. While with 3D printing, there was a lot of technologies developed around that made improvement in food industry, because now we can even print the sugar pads. That's very interesting, for example, for some custom-made wedding cakes. We can print the bride and the guy in sugar, But before this, we can scan them in 3D with only one iPad and small 3D scanner. After that, pottery design software is developing also, so we don't do anymore the pottery by our hands. We design it with the software, and after that we print it in ceramics. So if I want to have some custom-made dish plate, I will just design it, export my CAD file to the printer, print, and it's done. It's really to make the match between virtual and concrete real world on path. About 3D scanners, we have actually the 3D scanners that we can use with mini iPad, with the price of those scanners around 300 euros, and we can really scan everything, even colors. So for example, if I take you, I can scan you, completely have your 3D shape, and I can print a figure of you with your eyes, with your shape, with your beard, with everything. So we can do really 3D photography with physical photography with this. I mean, the people say there's no limit. There are the limits, but the limits are higher and higher. As I told before, if we start to manufacture the food with 3D printers for NASA, let's make some improvements and progress in this science and technologies. Otherwise, I can show you here on the next slide. This is, for example, printed cups, ceramic printed cups on the right picture. On the left picture are just some sugar cubes, also 3D printed. And the price of those machines is not so high. It's really affordable to the people who is concerned, bakeries and pottery, people who like to do pottery. It's around 10,000 euros. So those machines are really not very expensive, and they're they put the prices lower just to make them affordable to everybody. So actually, before we had 2D printers, and now we can buy for our home small 3D printer, make the parts, the toys for the kids, let them design and introduce them in 3D printing and 3D world from when they are young. I don't know if it's good or not, but it's what's actually happened. And yes, 3D printing is a very, very big, it's not a big science, but it's there is a lot of activities in 3D systems, so in 3D printing, so I think that we need more than 45 minutes to check everything, but if you have any questions about 3D printing, I'm here to answer for them. Ako imate pitanja, pitajte. Well, there is a few procedures. Procedures are different, but main principle stay the same. It's matrix type vector. That means layer per layer, and after that we get a part. If we have wax materials, all parameters are not the same if we have acrylate materials or if we have powder materials. I mean, there is a few kinds of 3D printers, so but the principle is layer per layer, so that's not changed. For even if you want to print titan parts or plastic parts, we will do it layer per layer. Well, about ceramics, this is a technology came out 2 months ago. It's not officially presented anymore, and unfortunately I cannot give you more details about this still final release on Euromold in Frankfurt this year. And if you are there, you will see me probably on the 3D system stand. Well, for every printer you have more or less one. For plastic print materials you have one kind of printer. For ceramic printer. For metal powder, metal printer, it's really every material has own parameters, printing parameters, and configured printer. So it's similar, but it's very different. I mean, if you buy some professional printer, you can't, and you have a range of 5 printing materials. You can't really, even if it supports 5 printing materials of 6, if you decide for one printing material, you can't really change with every bottle of new material. Today I want to use this. After that, I want to do this. And actually, we made a lot of improvements, and we have online material mixing. So that means we have our CAD file assembly. I mean, some even small car assembly, and we will customize the materials for wheels, for the body of the car, for everything. And during the printing procedure, the materials will be created for this part of the car or this part of the car. Here we can optimize, and even with rubber, we can print the rubber, harder rubber, softer rubber, and here we can optimize. But we talk about machines that cost around 250,000 euros, more or less. With small personal printers, for cheap printers, we have ABS material or PLA. And the only thing what we can modify is layer thickness. That's all. To go faster and have worse resolution, or to go slower and have some nicer resolution. Otherwise, it's really for professionals. When they decide one material, they know why did it. And we can't really change this. We can, but it's 2 days of work to adjust machine for a new type of material, because some things are not fully automatic yet. Any other questions? Yes? Well, yes, for sure. The 3D printing is used to decrease the costs, to not spend too much money for validation, to validate some concepts. For some parts, it's cheaper to print them than to start production of them. There is a lot of calculations, so you have graphics. How many, if you make 5,000 parts with 3D printing, it becomes cheaper than to make all industrial process for those 5,000 parts. Because those 5,000 parts, if you're going to manufacture them part by like unique parts, it will cost you a lot of money and time. And in the industry, everybody wanna lose less of money, and so that's why, for example, Bosch drill machines, you have the shells, left and right shell, right? Imagine with 3D printing how it works. We will design the part. Okay, we're gonna print it, both parts. We will see them, we will assemble them, we will put the electronics, mechanics, and we have a prototype of our drill machine. And for the holes for screws, if they are dislocated left and right side for 1 millimeter, and if we didn't see this during validation of our concept, and we made the molds for serial production, first of all, we started to manufacture something, we need to do it, and we have to repair the mold. And mold reparations for this kind of molds, it's very expensive. And we are talking about thousands and thousands of dollars, euros, whatever currency you want. So that's why, no problem. Well, 3D printers are using STL files, stereolithographic files, and that's me. But we have our CAD software with which one we will design our parts, convert it in STL, and after that, because the STL it's the basis of 3D printing files, and after that, with every 3D printer comes a software for processing, where we will just put our part on the 3D printer, simulate, check everything, and then we start printing. It will convert in his own protocol, and every company has own processing protocols, because this is some industrial part going very, very fast, developing very, very fast, and everybody will save the money and keep everything for themselves. I mean, it's the parts. Or yes, for sure, there is a lot of service bureaus worldwide. You send them, they can make you a quotation online. You send your STL file. They tell you a delivery date, how it costs you, everything, and they will manufacture it. I mean, I started with the 3D printing. I touched first time 12 years ago 3D printer. For a couple of years I'm working in a company who manufactures 3D printers, and since I started to now, this kind of manufacturing workshops for 3D printing are just exploded, the quantity of them. There is a lot of, I think that even in Hungary there is 2 of them, in Russia, worldwide, it's really worldwide. In every country there is a 3D printing workshops. So you send your STL file, you say, I want this, 5 parts, how many it costs, you receive all answers. And I can tell that it's really not the cheapest of manufacturing process. It costs something. If we go around the prices, materials are going, okay, for personal printers, kilogram of material of cubic decimeter of material costs around 70, 80, 100 euros. I mean, this is the selling price. The ABS is it's very cheap, but as they protect and want to make the more money they want, they protect it with some chips inside, and you cannot put other ABS because you get your cartridge with a small print and everything is inside. And even if you didn't finish completely, but after 50 meters it has to stop, it stops. And even if you wanna, you can't even smuggle and use your own materials, because everything's protected by RFID labels, locked. And yeah, I mean, they sell you like a 2D printing, like a normal. They sell you the printer, and after that, okay, we will sell you the material. And for professional and industrial printers, materials are going from 300 euros per kilo up to 1,000 euros per kilo. It depends of the characteristics, properties of the materials. For example, some Formula 1 manufacturers like Sauber, Petronas, Ferrari, and others are using SLA machines with the charged resins. The resins are charged with some granules of, I cannot develop you what exactly, but, and it's very strong and it's very light. We have 1 decimeter, cubic decimeter weights 1.5 kilos. It's even less than titanium. It's very resistant, but a kilogram of this material costs around 1,000 euros. And they buy something like 200, 300, 600 kilos in every 2-3 months. So yes, it depends on the character properties of what you own, but it's very expensive. Yes? This is no, this is plastic material, something like, yeah. Yes, rigid, but don't break so easily like a carbon fiber. It's between Kevlar and carbon fiber, something between. And they use them for first for development, and after that in Formula 1 there is few parts 3D printed, but the most of them is carbon fiber. Just because of the weight. Because every gram in Formula 1 is important, so. Yes, next question? For a lot of parts in industry, not especially Formula One. Yes, you use the parts directly after the printer. I mean, I'm on head of production site of materials in Switzerland, and I have in the industry on the machines 3D printed parts with the machines, the supports, a lot of things, even things for ventilation. We can even make. There is you go on the website of 3D systems, you will see even instruments 3D printed. The drums, all structure of drums 3D printed. The guitar also 3D printed and all. And we can print all parts we would do mechanically, and after that put all electronics, electrics, and have functional prototypes. Yes, we have. Before this, I was working in a company who was manufacturing, who still manufactures inks for security inks, and we were making. I was designing and making the detectors, and I was just putting optical parts inside, and the rest was 3D printed or rapid prototype made. So we can do really a lot of things, and we approached really prototype to industrial part to use. And this distance was before very big, because 20 years ago a 3D printed part, you look at it breaks. Now we have really functional things, and a lot of people buy small printers to make parts for their copters. I mean, one of my hobbies is skydiving, and I made some supports for my GoPro cameras in 3D printing, and it resists 200 kilometers of hour of free fall and all the stuff, so it works. Otherwise I would never say that it works. If it works really, yeah. Yes. It's applied during the printing, and it's applied on the first 2 millimeters of the part you print. And we work with 396 colors, and it makes very realistic figures, parts, puppets. I don't know, dolls, call it how you want, because it's still quite strange to see somebody to make the 3D scan of the person, to print this, and to see the same in plastic but realistically and just small. So yeah, it's during the printing, and there is few procedures for this. One of these is with some chemicals, so the material change the color. We put not the color, but some solvents, and it will just change the color. On this, it depends of how many of solvents you put. Yeah. Next question. Yes.
Is it better than milling?
Well, it depends for what. If it's sometimes it's not faster. But if you have some holes for some blocks that you can't make with a drill machine because it's deep inside, and you need some curve and something like this, then the only solution is 3D printing, or like I showed on the slide before, you need 5 days, 20 tools, 50 screws to make something look like. But sometimes we need only one block with a specific structure inside and shapes inside, so only 3D printing can helps us. Yeah. So it depends what you need. For some simple parts, it's cheaper to drill it, but for some very complicated parts, only way to do it is in 3D printing. Yeah.
What are the future economics of 3D printing? What do you think? Will it change the way we manufacture? But will it be a replacement for old school molding and milling? And is it a smart idea to invest in 3D printing companies?
Well, probably it is a smart idea to invest in them, but otherwise I don't think that will change the molding and big productions. I mean, in China they will still do a mold production, not 3D printing. For yeah, they will still do the production, but 3D printings first of all will bring another way of thinking of creation and design. It will develop all techniques around the printing, like 3D design with the 3D glasses and a pen, a 3D pen, and we just design in front, like with it will bring it will bring us in some virtual reality, and for some really specific parts, there we can have some. It is very interesting. So. And otherwise, the applications of 3D printing are developed after 3D printing. We start with 3D printing 20 years ago to 30 years ago because to make the life easier for mechanical engineers, more or less. Actually, we have everything is printed in 3D and with a lot of materials. Even you can print, go in your bakery, you say I want this on my cake, can you please print me this, and they will print it. You can manufacture jewels custom made also, and it's really a wide range of application of 3D printer. Naturally specific 3D printers for specific applications, but it will cover a lot of things, a lot of uses, but molding production will still continue, that's for sure. Because we cannot have enough of printers to manufacture so many parts. Any other questions? Well, then thank you to listening me. I hope it was not so annoying, and if you have any questions, I'm here 3 days, you can just ask. Може и